Welcome to a recap of the Structures of Equality PLC held January 12, 2023. During this PLC, we were introduced to Julie Russo, the creator of Structures of Equality. Julie gives a brief overview of each type of structure and provides an example. As you move through this video, there will be title screens, and you're welcome to move to one of the structures that you prefer to watch or the example at the end. Julie has been in the business of supporting elementary teachers for over 25 years as a math coach and trainer. She developed Structures of Equality to help students understand math word problems. It's a powerful reading comprehension tool. She guest lectures at NC State, works with Wake County schools, and supports some teachers and staff at an inclusive school in Jamaica. There are 3 structures of equality: parts equal total, compare and repeated equal groups. And these 3 structures of equality can be used to diagram elementary problems found in the NC Unpacking document. Julie's going to lead us through using each of these types of structures of equality and then provide an example at the end.
How you want
if you want to go ahead and click, it's at the bottom of the agenda.
So I'm so excited to be here. Thank you for taking the time to go over some of this stuff with me. This document that is here in front of you is called Structures of Equality Explained, and it's a one-pager that explains my 20 years of work with math word problems, and it's very concise. So the first thing I want to talk to you about is what is a structure of equality, and that's up there in the top left corner. First and foremost, it's a graphic organizer. So when do we normally use graphic organizers? Can somebody come off mute and tell us when they've used graphic organizers in the past?
Writing, use it a lot for writing.
Allison, yes, Allison, thank you for sharing. Typically, we use them in language arts. Sometimes we use them in social studies. Sometimes we use them in science. We don't often use them in math, but we know they're an effective tool. So really down and dirty, this is a graphic organizer. The next thing is it represents equality. All 3 of these structures of equality represent equality. All structures of equality have values and labels, and it represents the structure or the relationship in the story. These pictures, you've seen them before in your math textbooks. You've seen these kinds of pictures before. They're called, some textbooks call them bar diagrams. Sometimes you'll see them as tape models. So those terms cannot be used interchangeably with structures of equality. You can call a tape model maybe a bar model, or a bar model a tape model, but a bar model is not exactly a structure of equality. And I'm telling you that so that when you are talking to other people, you can say this is a bar model, or you can say this is a structure of equality. Most people won't know what structure of equality means. So as long as the diagram has values, labels, and it represents equality, it is a structure of equality. If you use this in your training and you mention structures of equality, just so you know, this is something that I created to share with teachers. So you can use this freely, but you cannot profit off of the term structure of equality. But these documents that I share with you, use them freely, use them often. All right, so again, graphic organizer, representation of equality, values and labels, and it represents the structure or the relationship occurring in the math story. So there's only 3. So all 3 of these, I know you've seen this document before, all 3 of these can be used to represent all of these problem types. About a structure of equality to a student, they have to ask themselves, first and foremost, what structure of equality would I use to represent the story given? So now we're going to talk about that. So there's 3. The most basic is parts equal total. Okay, so parts equal total structure, and I have bar models and tape models in parentheses, are helpful if a math story describes 2 or more parts being put together, composed, to form a total, when a story describes a total being taken apart or decomposed into 2 or more parts. So now's a good time for us to get our piece of paper out. So what I want you to do is get your piece of paper out that you have, And I used to, when I was in the classroom, I used to say, fold it hot dog style. So take your piece of paper and fold it hot dog style, crease it. And then if you're having trouble following with me, raise your hand or put your hand up. Once you've done a really good crease, if you have scissors, that's better. But if you don't have scissors, once you've done a really good crease, rip it down the crease. Okay, so now you have 2 pieces of paper. Okay, and then fold it hot dog style again and rip it down the crease. So this is my structure of equality. When the students get so they understand the structures of equality a little bit more, I always have 2 bars like this, and then the bottom or the top bar can be divided up into the parts. When we're just starting to learn about structures of equality, I give them 2 parts bars like that. So go ahead and show me that.
Doesn't matter how big or small they make one.
No.
Doesn't matter how big or small you make
Nope.
one or the other.
And if you can get your hands on some of these laminated, they're pre-laminated sentence strips. These are really, really, really a great resource to use. Great, great resource. All right, so now that we have our paper strips cut up, we're going to go back to the parts equal total structure of equality. So let's talk about this. So parts equal total structure are helpful when a math story describes 2 or more parts being put together. Point to the bars that represent your 2 or more parts being put together. So identify those or hold them up.
Hold on.
Yay!
Thank you,
Thanks,
Allison. Yeah, you
Yeah.
might want to turn your cameras on, hold up your sentence strips. We'd love to see you do that. That would be great.
Okay. And then it says being put together to form a total. So then hold up your bar that represents the total. Right. Exactly right. So when you're doing this with your students, you want to do the same exact thing. So then it says parts equal total can also be used when a story describes the total being taken apart into 2 or more parts or decomposed into 2 or more parts. Okay. Yay, Paula, you got it. Good job. Okay. So let's look at this story here. Miss Felder has 8 balloons. 3 are red, the rest are yellow. How many balloons are yellow? So Miss Felder has 8 balloons. Someone come off mute and tell us what bar should the 8 go on, the total bar or the parts bar?
The total bar.
Yay, thank you. Thank you. It should go on the total bar. So when we write this out, if you would go ahead and do that, write that out right now. Write out 8 balloons on your total bar. And it's important to identify the unit because balloons plus balloons equal balloons. When we're doing this, we need to identify the unit. It's not yellow and red, it's balloons. So write balloons on the total bar and write 8 balloons. You got it. Saida, am I saying your name right?
Yes.
Thank you, Saida. You got it. All right. And then go ahead and, oh, here's a trick. Now, some kids are going to be able to do this and some students might not be able to do this. 3 are red. Now, we know as grown-ups that we want to put the 3 on the smaller bar. That's not going to come right away. They won't know that right away. So depending on where you are in your instruction is dependent upon how you handle that. If a student puts the 3 here and you're just getting started, I think that I would just continue to move on. I wouldn't correct that behavior. But as they're starting to get some nuance with this, then I would tell them, yep, the 3 is going to go on that smaller parts bar. So go ahead and write three balloons. And then I put red in parentheses. The reason I put red in parentheses is because I want to identify what type of balloons they are. But I don't want to put red balloons because red balloons you cannot add red balloons to yellow balloons. You can only add like units. So balloons plus balloons equals balloons. But it's helpful for the student and the teacher to identify what group you're talking about. So then your blank is blank balloons, yellow. So my argument, and I have lots of proof to it, is that if a student can model this story using this structure of equality, if they can do this, they can solve any problem you give them if they have the strategies to do so. Number line hops, whatever your strategies are. This is where the issue was when I was teaching in the classroom and when I was a mentor and a coach. This is always where the issue is. It lies in the comprehension of the story more than in the computation. Okay? Does anyone? Structures are helpful if the story describes a situation where quantities are being compared. So here we have two quantities that are being compared. Sometimes the question asks for the smaller value. Point to the bar that represents the smaller value. Sometimes, yep. Sometimes the question asks for the smaller value when given the larger value and the difference. Where's the difference? This is tricky. Where is the difference? This one's the smaller value. Yes, Allison. The different, yes, Paula. So Allison showed, if you didn't see it, Allison showed this part right here. Paula showed the desk, or it's this part right here. So the difference can be here, or the difference can be here. So let's read that one more time. Compare structures are helpful if a math story describes a situation where quantities are being compared. Sometimes the question asks for the smaller value when given the larger value and the difference. Right. Okay, next one. Sometimes the question asks for the difference between the two values. The difference between two values. So the difference between two values can be the fewer, which is down here, or it can be the more. Those are the easiest type of compare problems. Allison has 3 apples. I have 5 apples. How many more apples do I have than Allison? So those are the easier ones when you're looking for the more or the fewer. Okay.
Would you ever use this to represent the difference? Or do you want to point to that blank space like that's on the desk?
That's a great question. So let's talk about that some more. So these structures of equality only model what somebody could hold. They only represent what you could hold in your hand. So only what you could hold in your hand is represented here. I'm not going to use a physical representative. Now, that's not true for all bar models. Lots of tape models do show the difference, and they show it with an oval or different things. In my brain, when I'm working with kids, what I've seen is that the models that only show what they can hold in their hand are the most effective models. So here's where it gets tricky in doing that. When a question asks for the fewer, because this model you can't show the fewer. Okay, so this is let me go back to the last one. So the last one says, sometimes the question asks for the difference between the two values, and sometimes the question asks for the larger value when the smaller value and the difference is given. So I take this, and if you want to do it too, it'd be great. And I draw a dotted line right here. And this is something I stumbled upon. And I coined it the line of equality. I made that term up. I coined it the line of equality. I was teaching a 3rd grade class, and there was a question about how many fewer. And I had to pull out the kids that were at risk. And the question was how many fewer. And so the young lady went right to more, to tell me the more. And I said to her, well, that story doesn't, you're right, but that story doesn't say something about more. It says something about fewer. How did you get there? And asking kids to get to that logical spot is challenging, because if I know that Joy has 2 fewer than me, then I have 2 more than her. It seems pretty simple for us, but it's not for kids. So I draw that line of equality on here. And this is huge. I did this today in a second grade class. So when I do this with comparison structure, so say the top value of this comparison bar was 6, and this bottom value is 4. Okay. When I use comparison bars, I like to write the number out to the side, which is challenging. You need more stuff. But the reason why I do that is because I can write 4 apples here. So say I have 4 apples. Joy has 2 more apples than I do. If I have 4 apples and Joy has 2 more apples than I do, where does the 2 go? Yeah.
Yep.
Yes. The 2 goes over here. So I know that this is the line of equality. So I know something super special about the value of this bar up until this point. I know this is my line of equality. Structures of equality represent equality. So I know if this bar up until this point equals 4 apples, then what does this top bar up until that point have to equal?
Four.
4. It has to equal 4. Yes.
Right.
And that's a challenging concept for kiddos. So I like to put my total out here to the side. Can't see. My total's out here to the side on comparison. This one doesn't need it, but the top bar needs it. So that when I'm doing this, I can say that 6 is decomposed into the more, which I told you, Joy had 2 more apples than I did. And the part I don't know, once I do this, I do 4 apples. So how many apples did Joy have?
6.
6. It seems so easy, but it isn't when you're in front of kids doing this. It isn't. So today in the That's right. And the final step to that is to ask, what does this one thing on your representation mean? Well, that's 1 candy bar. What does this mean? Well, that's 1 candy bar. What are these, however many more you had? What do these over here represent? The extra or the more that one had over the other. So going back and just making sure they understand the representation. But it sounds like you're on the right track.
Okay. I didn't do the last part, but I did that. But then when I went back again with a similar question, but a bit more, a bigger number, they didn't get it. So I think I still have to do a couple of practice problems.
Lots of practice.
Yes.
These are the hardest ones.
Right.
All right. Thank you for sharing that. So this next one is a repeated equal group structure of equality. So you can use repeated equal group structures, and you've seen them as arrays and area models in your math textbooks for years and years. This is nothing new. They're helpful if a math story describes putting equal groups together or taking equal groups apart. And I try not to say they're helpful for multiplication and addition. I try not to say that parts equal total are helpful for addition and subtraction, because I want this model to represent what's happening in the story. And then I want the students to solve it in whatever method that they feel comfortable solving it with. And if we say this is an addition story, and then they want to, use a different strategy, I think we're taking away some of their thinking with that. So I'm trying to be careful not to say this is a multiplication or addition structure of equality. So we can use a repeated equal group structure of equality when we're putting equal groups together, which is a repeated addition or multiplication, or we are decomposing into equal groups, which is typically division or repeated subtraction. Okay. So there's 2 different ways to do a repeated equal group structure. This is new to my thinking. I hadn't added this before, but it totally makes sense to me now. So this is a typical array. This looks more like this model. And we can use this model because we're putting groups together just like we're putting groups together here. What's different about these groups from these groups?
Those groups are equal.
Yes, those groups are equal. Thank you. I'm not sure who said that, but
Beverly.
Beverly. Thank you, Beverly. Those groups are equal. So here we have a typical math story that you'd see in a 3rd grade textbook. There are 4 bags with 2 oranges in each bag. How many oranges are there in all? So structures of equality have 3 things. They are a representation of equality. They have values, and they have labels. And from my many years of experience, I found those 3 things are vitally important for comprehension. This is a reading comprehension tool. And if the students have those 3 things, that means they understand the relationship in the story, the relationship of equality. They understand the thing we're counting, the unit, and they understand the values. And they understand that the model represents the story in and of itself. Questions about that?
As we move into the next segment, Julie is going to provide an extended example of this problem. She's going to walk through how to take the numbers out, add in different numbers, and help the students solve the problems. You may want to make note of this released 5th grade EOG problem as she walks through the example.
Somewhere in the slides. Awesome. Okay.
So this is a 5th grade released end of grade test question. And the challenging thing with that question was it had decimals. The question in and of itself, not so challenging. But what I found, especially with 5th graders, is that if you give them a problem with really big numbers in it, or with fractions in it, or decimals in it, and if they're not a great reader, they get frustrated and shut down. But if you present that same problem in this format, does this feel threatening? Do you think a 5th grader would be threatened or shut down by this? I don't think so. They won't. And if the numbers are an issue, if we're struggling with fractions or decimals, and you're real.
Oh, you got it. Okay. Yeah.
Oh, I don't have it.
Oh, no. Okay. There you go. Yeah.
Really, this is a reading comprehension issue. So that's what we need to focus on. So the first thing I would do is have the students read this question 2 times in their brain. And I ask them, I say, once you read it 1 time, put your finger up here in front of you, like this. Once you've read it twice, put your finger. I need to read problems 2 times to figure them out. And sometimes I still don't understand what they're saying. So to be sure, the kiddos need to read it 2 times in their brain. So I ask them to do that, and they've read it 2 times in their brain. And then I start talking about the problem. And I ask weird questions. I say, who are the characters in the story? And they tell me who the characters are. And then I say, where do you think they are? What do you think the setting is of this story? They could be out in the park. Who knows? They could be on a track. Then I say, what are they doing? What's the verb? What's the action word? And they tell me what the verb or action word is. Oftentimes, I don't even show the question. Why do you think I don't show the question?
So they won't feel intimidated by all the words.
Right. Sometimes all the words can be intimidating. They don't feel intimidated by the words. What are these kids programmed to do when we give them a word problem? What do they want to give you?
Just whatever the answers.
Just the answer.
They just look at the numbers and don't read.
Some of you are mouthing that too. Yeah.
I just want to get the answer and I want to get done. So in some ways, this kind of frustrates kids when I don't give them the question. They're like, this isn't a math problem. What are you doing? But it forces them to go back to what we know the issue is. It's comprehension. It forces them to go back to comprehension. Okay. So once I've gone through that and I know they can visualize this, we had lots of English language learners where I was teaching in the classroom. So comprehension is huge. And if I still felt like they needed some support with this, we would choral read together. Anybody that wanted to would read with me. So I would read this out loud with any, I'd never made anybody read anything out loud, but anybody that wanted to, we would choral read. Or if I knew I had confident pairs that could read together, they would pair up and read together. So there's lots of different strategies, and you all know those already, I'm sure. So then, let's see. Do we have, I think we can use the backs of these. So you wrote on one, you can use the back of it. So be ready to draw this out using the back of the strip that you created. This is going to be challenging because of the extra piece of paper on the side that we talked about. All right. Here's your story. Is that backwards?
Nope. 5 miles fewer than, yeah.
Emily.
Yeah, and Alyssa walked 8 miles. Yeah.
This language is tricky. The fewer and more language is tricky. So let's try to draw this out. So first of all, I'd say, if you had two different strips, colored strips, I'd say, hold up this, who walked farthest? That's what I would say. Who walked farther? Did Alyssa walk farther, or did Emily walk farther?
Emily.
Emily.
How do you know that?
Because Alyssa walked fewer miles than Emily.
Right. Alyssa walked fewer miles than Emily. So hold up the bar that represents Alyssa's miles. So it's going to be your longer bar.
And this is a good opportunity to tap into that comprehension, because a lot of kids are going to think Alyssa walked the furthest.
It will, because the language is so tricky.
Or Alyssa walked 5 miles. Yeah.
Right.
Yeah.
So,
yeah.
I mean, these, it seems basic, but it's not. The language is so tricky. And so forcing them to draw the model really helps you as a teacher understand if they're comprehending what's happening. So
why would Alyssa be the longer bar?
Alyssa walked 5 fewer miles than Emily. Alyssa's bar is not the longer bar. Alyssa's bar is the smaller bar. Did I mess that up?
I thought you said the longer bar. That's why I was confused.
Alyssa walked 5 fewer miles than Emily. So Alyssa's bar is the smaller bar. Let's put an A on the smaller bar.
Would you also label the smaller bar 8 miles, or do you want to hold off on that for now?
I think because the way my brain is processing right now, I need to hold off on it.
Okay.
It depends on how your brain's processing, but I want to hold off on that. So we know that Alyssa walked some fewer miles than Emily. So Alyssa's got the smaller bar. And then we know that Emily has the longer bar. So I put an E on Emily's. All right. So Alyssa walked 5 fewer miles than Emily. Alyssa walked 8 miles. So now we can go, okay, I know how far Alyssa walked. How far did she walk, Allison?
Alyssa walked 8 miles.
Okay. And then what can I do right here?
I did a 5 on the other side of the line of equality.
Right. But you jumped to that, didn't you?
I did. So you put an 8 on the side right underneath.
5 is right. I mean, you're right putting 5 here, but would the kids automatically know to put 5 here?
No.
Because they both walked 8 miles.
It says 5 fewer.
Yeah.
So what I would say is, where's the fewer on your model? Matroba, where's the fewer on the model?
I did the fewer, yes, on the other side of the line.
Yes.
But
That's the more. Over
Right.
here is the more. Where's the fewer?
So is it up in the blank space?
Yes.
Yeah.
Oh, yeah. So, Matroba, I didn't get to you. I'm sorry about that. But the fewer is over here. This is where the fewer is. It's the table. So then you have to say, okay, if that's the fewer, where's the more that Emily walked? And that's how you get down to here, Allison, where you put the 5. And we need to put our labels in here. When I work with kids, I say, you know, this is hard for adults' brains to figure out because it is. So now that I have that, I can come back and put my 8 down here because my line of equality tells me that's where that lines up. So if that smaller bar is worth 8, then this part of this larger bar is 8. So this bar, this larger bar, is decomposed into the 5 we know and the 8. So then once we did all that hard work, then I would show them the question. Wow, how many miles did Emily walk? And then they use their strategies. Number line, cubes, calculator, whatever strategies they need to do that. So this 5th grade question, the actual question, it was from an EOG question. Let's put it right here if we could see it. And so what I would do if I'm glad Joey's here next to me. What I would do if I was working with 5th grade and I felt they were ready, I'd put the actual values in from the EOG test question. There's a video that I'll share next time. It's called Do Less, Get More. If you go on YouTube and you search Do Less, Get More, there's a gentleman that talks about just what we're doing right now. And it's about how important it is to get deep into these kinds of problems and really understand them at a deeper level. And that takes a lot of time. We couldn't do 20 problems like this.
Right. It just noticed how long it took just to dive into that one with the simple numbers.
Yes.
So, but it's worth spending that time with your students because they're going to recognize this is a comprehension tool the more you practice it.
So we had a 3rd grade teacher that we worked with, and he would not accept any paper that didn't have a structure of equality on it.
Just to recap the bottom line and some takeaways from this PLC. Structures of Equality is a graphic organizer. It has a representation of equality, values and labels, and represents the structure of the math story and is a very powerful comprehension tool. Julie very happily takes questions from Wake County Public Schools teachers, and her email is included at the bottom of this screen. If you have any additional questions, you can contact Tama or Joy at the Special Education Services Math Department.